All right, so what I want to talk about next is going to be normal maps. So when we talk about normal maps are a modern form of artificial surface relief. So when we talk about artificial surface relief, what we're talking about is altering the surface of an object so that it looks like it has details there, but in reality it does not. So that is what the bump map is. Now, the bump map is one of the earliest forms of artificial surface relief, but more contemporary tools tend to work with normal maps rather than with bump. So what are they? If you come in and you look at Polycount normal maps, they have a great section where you can read about what normal maps are, all the various aspects of them. There is a lot to normal maps. So just be aware that they are a very important map, especially for anyone looking to go into games. Long story short, what we need to understand is the difference between bumps and normal. So when we talk about a bump is going to be a grayscale map. And we already know that 50% gray is going to be flat, and anything above that is going to read as an elevation, and anything below is going to read as an indentation. So when we think about a bump map, basically it's whether the surface is like this or like this, right? It's going up or down, and it's doing that with a single channel. So it just has one channel of information, which is going to be height, black and white. Now, how does normal differ? Well, normal maps are going to utilize the red, green, and blue channel to indicate different directions the light can be striking. So whereas something like our visor for our robot might read like this as a bump, with a normal map, we could make it read like this, having different angles, because we have three different channels where we could indicate different sides using a normal map. So in short, normal maps are kind of just an evolved version of bump. We gain more information. Now, where are normal maps used? Where are bump maps used? Normal maps are used heavily in the video game industry. They are the secret to creating realistic looking low poly assets for games, and they have been the secret for a long time. They are also used in film to produce high frequency detail. So that's the kind of stuff we're doing, the bumps on the surface, the metal indentations, that type of stuff. Bump maps are still used. Bump maps do have the benefit of rendering slightly faster, but the speed at which they render is negligibly faster, meaning that you really don't notice it in this day and age. So that is another factor. Okay, so that's something to kind of be aware of. Now, what are some of the benefits of bump maps? They're easy to make in applications like Photoshop. We can't inherently make a normal map. We need help with it. So normal maps, you tend to need special software to help you with, and we're going to explore some of those. Whereas bump maps you can make with any old imaging editing software. So if you're wondering why we started with bump maps, there's your answer, because we can't really make them inside of Photoshop inherently. So we're going to explore that. Now, there are a couple different normal map types. So let's go ahead and talk about the normal map types and where they are used. So the number one, most used one is going to be tangent space normals. And tangent space normals are what we're going to use exclusively in games nowadays, and pretty much in film. The other normal maps don't have many uses. If we go ahead and pull up Google, we can actually see the difference. If I type in a tangent space normal map, and we go to something like images, you'll be able to see the difference in how it looks. So I'll go ahead and pull up this first image here since it has the two spaces that we tend to care about. The tangent space map is going to be this one over here. So you can tell it's tangent space when it has this sort of violet color, sort of a purple color. And this is going to be what we're using. And once again, that is going to be tangent space. So what is so important about tangent space maps? Tangent space maps have the ability to move with the object. So in short, they can move, they can deform, all that good stuff. Essentially, we can think of them a bit as a bump map plus one. Now, because of this, they have become the primary type of map used when it comes to artificial surface relief. But there are other versions which is what we're seeing here. This would be what we would consider a object space. Sometimes it's referred to as world space, but object space is what it's usually called in baking softwares. Now, when you work with this particular type of normal, one of the challenges is it can't move. All right, so when we talk about object space, it can't move, and you can tell it's using the red, green, blue channels because it's very much red and green. So that's going to be something that you will notice. That is the number 2 map, which is going to be world/object space. And like I mentioned, the downside to these is they can't move. The upside is they are faster, so sometimes they can be used for environmental assets that aren't going to go anywhere. But generally speaking, any sort of environmental piece might be used again. And because of that, it kind of makes them useless, because if you move it in a different spot in the scene, you can't recycle. So these are kind of old. We don't really use those so much. Tangent space, though, these are thumbs up. Good to go. Now, how do these work exactly? The different colors that are mapped, the red, green, and blue, are going to correlate to an X, Y, and Z axes. So when we have that map and you're looking at it, what you're essentially seeing is each color transition is changing the angle of the surface and the way it is facing. So that is the idea there with the normals. All right, so that's a very brief explanation. It could definitely be delved into a lot deeper. And like I mentioned, I encourage you to read up on it. There's a lot of information that I would forget to cover that I'm sure is covered in documents such as polycounts. So how are we going to create ours? Well, there's a couple of different options we have to create normal maps. So when it comes to normals, you can create them in Photoshop. Something to be aware of. Sometimes you need assistance with this. You can have various things like plugins that can help you, but there are native tools in Photoshop that allow you to. They are a pain to use, though. They are very convoluted. You have to go through the 3D system, and they actually tend to not look very good, but you can find plugins. One of the ones I use is a XNormal plugin. If you look into XNormal, XNormal is a free normal map baking software. It is very old, but what's cool is it does have a Photoshop plugin that allows you to do conversions. I don't really use this one anymore, though. I use their plugin for dilation, which is to fill in your UV seams, but I don't really use this too much for normals. You could also use a software called Crazy Bump. Crazy Bump is another good software for creating normals. The downside to Crazy Bump is Crazy Bump costs money. So it is one of those softwares that, does take money. The cool thing about Crazy Bump is you can convert to things other than just normal maps. You can get height maps and you can get ambient occlusion maps. So some nice advanced types of maps that can help you fill in your details. This is taking a while here, but you can see how they've converted this photograph into a set of normal maps here, which is really nice. Another software is Knald. I haven't worked with Knald before, but I had a colleague a while back who did a lot of Knald work, and this is another one that can convert. Once again, this does cost money. So those are all going to be different options. You're going to have your XNormal for your bake. You're going to have your Knald. You're going to have Crazy Bump. All of these are used. You might also have other softwares that can generate normals in some other way through things like sculptural detail or paint detail, such as ZBrush, Mari, Mudbox. These are going to be your sculpting softwares that can achieve this. And there are other softwares that can inherently convert data, for example, Substance Painter. We're not going to get into any of these. I'm going to show you my own secret weapon, which is Smart Normal. If you type in Smart Normal, usually it's the first one that comes up. You can see it's this Smart Normal Map 2.0 smartpage.net. And what you can do with this website is you can load an image in and it creates a normal map for you. Now, with things like Nulled and Crazy Bump, you get a lot more control, but I find this actually works really well. So this is actually the website I use professionally. I don't do a lot of high-end film stuff, so this website does have some limitations. You can't upload massive files. So if you're working at an insane resolution that the internet can't handle, you're not going to be able to convert this here. Then you're going to need Crazy Bump or Knolled. But working in the game side of things, this works great. There's really no map I've ever had that I couldn't convert. So how are we going to get this to work? Well, what we need to do is we need to come over to our bump map and we need to export this out as a format that the internet can read. So that's either going to be a JPEG or PNG. We're going to want a PNG. A quick way to get a PNG out of Photoshop is to come here to File. And if you take a look in here, there is a section where we can export right down here. And you'll see that we can select to quick export as PNG. So we can click that. And we can navigate to our source images. We can come into characters, robot, and in this folder, I'm going to name this height map. And while I'm at it, I'm going to copy this directory real quick and save. And we can hop back over here to the Smart Normal website. If you didn't catch the URL, you can see it here. It's smart-page.net/smartnormal. And with that, we can go ahead and click on load. So if we go to load, this is where we can load in our image. Paste our directory up here and grab our height map and hit open. And you'll see our information loads in here. Now we can scroll around to see this. There's some cool controls we have over here. We have something called a bias dial. This will increase or decrease the bump. So if I go ahead and increase that, we can see the details a bit better. You notice that we're barely seeing these, so I might actually be able to bump them up in Photoshop before bringing them in here, or bump them up in here to my liking. You can also invert channels. We don't need to worry about that. And you can also blur. So if you didn't like the sharpness, you can click blur here and you can actually blur areas. So what we want to do is just kind of calibrate our height map a little bit better to come in here. So I'm going to hop over to Photoshop, and I know we took a painstakingly long amount of time making this look good as a bump map, but we can increase these quite a bit. So for example, I can make things visible to my eye, which is nice, and we can adjust them in there. Let's do the same with the metals here. Where did I control the opacity on these? Oh, I think I just made it a really close color. Let's make it a little bit less close. Let's go ahead and make this 40 like we did originally. And re-export this as our height map and adjust it from there. So I'm going to re-export this. Just do a quick export here. Height map, save. And we'll reload this. Now, if I come up here to load and we load in the same one, it's not really going to update, which is something I don't like about this website. So what I could do is just create another tab, type in that Smart Normal, pull that up, and we can reload this. So I'll just reload it into a fresh one. And you'll see with the increased height map information, we get the detail a little bit better here without having to go crazy with the bias. Now, normal maps aren't as sensitive as bump maps. So with the bump map, I had to go like 0.01 with the noise. And here, I don't. As long as I can see it, we're good. And it depends on how much I want to see it. But this has a nice bit of roughness to the surface. I could increase this if I wanted it to be a bit more aggressive in those areas. And I'm just holding down Control and middle mouse wheel scrolling to zoom in here. Standard web commands work, but we can play around with this to find what we like. And like I mentioned, what you see is more or less what you get here, a lot more with the normal maps than with bumps, which is kind of nice. So we can get a better feel for the intensity that we're going to get out of here. I think that looks okay. So once you like this, you can click the save button, or you can also right-click save. I think you have to right-click save either way. We can do save image as, and we can paste this right back into our directory here for the robot, and we can make this our robot normal map and save. Now we'll look at how we combine normal maps later when we get into creating our room scene. But for now, we'll just utilize this as is. So how do we hook this up? Well, we hook this up in the same way that we hook up our bump map. So we can take our file here, And we can convert this, or we could just delete our bump map. And I'm going to highlight the nodes for that and hit delete. And in here, in our geometry node, where we plugged in our bump, we're going to insert our normal map. So you can just click your file over here, hook up that file, and click on this and set this to be our robot normal map. Now, if you look at this, it's going to look all sorts of awful. And that's because Maya doesn't know it's a normal map yet. So this bump 2D node here, if we click on this, it's where we can set our various map spaces. You'll notice that it is currently set to be read as a bump, but we can change this to be one of the various normal type maps. And you'll see we have tangent normals here and object normals. We want tangent space. Like I mentioned, that's the type of map we produced, and you can see the result here. Now, you're probably still thinking, whoa, that looks a bit strange, and you are absolutely correct. When you're working with tangent space normal maps, we need to click on the file here, and we need to convert these over to linear space. So what does that mean? Well, when you click on this file, the color space here is currently sRGB. This is a complicated topic. If you guys want to look up linear workflows, you can. There's videos out there. But the idea is this deals with gamma. And when you deal with an sRGB gamma curve, that's the standard red, green, blue gamma curve images have. It looks a bit like this. It has more values in the darks and less values in the lights. And it's designed to operate like our eyeballs. When an image is projected on a computer screen, we're basically seeing an sRGB space. But we want it to operate in something called linear space. Linear space is going to be when the gamma curve's a straight line. And this is how images are actually stored in your computer, but this is how they're displayed. So they're displayed in sRGB, but stored in linear. So we can convert that by coming over here to sRGB, clicking this drop-down menu, going to display, and selecting the gamma we want to use. Now, depending on what gamma space you're working in, you might want to change these. We're going to want to go to utility and raw, and that's just going to use the raw data that the computer has. We don't really want to convert to any of these ones here. So we'll just go to utility raw, click on that, and now our normal map will be seen in all its glory. And you can see we're getting a much better look than we had before with the bump map, with it actually being visible to our own eye. You can see the difference there. In here, we can actually visually see these. And if we pull up our character, you can see that we can actually visually see the bumps here in the normal map. As a challenge, what I want you to do is I want you to try creating a normal map of your own. What I would suggest doing is starting out by creating a height, trying out the Smart Normal website here, utilize that website to do your conversion, and then go through the process of applying it. We will be using normal maps much more heavily in the coming projects, but that's a brief overview of what they are. Now, as an additional challenge, what I want you to do is do some reading on normal maps. Don't just take my word for how they work. Actually delve in, read about it, get to know how they work, where they're used, how they're made, because it will make a massive difference in your artwork moving forward when you get into more advanced workflows. All right. So with that, let's go ahead and take a look at how we can adjust some additional channels such as emissive, and then we'll be done texturing.